All right, ladies and gentlemen. So today we're going to add an extra step here to solving rational equations, okay? Linear means that all variables will only have exponent 1, okay? In other words, not a 2, not a 3, not a 4, nothing higher than a 1. So they're all going to be linear, okay? Now, the way to approach these problems is not to cross multiply, okay? What we're going to do instead is we're going to get rid of all fractions here. And to do that, we need to find the lowest common denominator, okay? So in other words, we're going to multiply each of these fractions by a factor that will cancel out the denominator, okay? And so notice here we have 2x and 2, and then you could think of this as over 1, but we're not going to write that. So 2x and 2, they have 2 in common, and then it needs an x. So what I'm going to do is I'm going to multiply everything by 2x. So multiply by 2x here, multiply by 2x, and multiply by 2x. Okay? Now, what that does to each fraction is it cancels out the entire denominator. So notice here, the 2 here cancels out that 2. So I could cancel out the 2's. The 2x here cancels out that 2x there. And then there's no denominator here, so there's nothing to cancel in the denominator, okay? So what we're left with is just all numerators, okay? So watch this. 2x times negative 2 is going to be negative 4x. And then the 2x and the 2x cancel out here, so I'm just left with plus 9 equals, and then notice here, just the 2's canceled out, not the x, so I have 5 times x, which is 5x. And look at that, no more fractions to deal with. And so we can just solve here for x by adding 4x to both sides. And we end up with, I'll just write it like this, 9x equals 9. So put 5 plus 4 is 9 equals 9. Okay, divided by 9, x equals 1. And that's it. You have it there. Okay, let's look at the next one here. Notice my denominators are 3x and 3 and x. So 3x is going to be what we're going to multiply everything by. And so I'm going to just put the 3x right here. Okay, and 3x right there like that. So notice here, in the first denominator here, the x cancels only. Right here, all cancel, the 3x and the 3x. And then right here, just the 3's cancel. Okay? And so what are we left with? We're left with a 3 times negative 6, which is negative 18. We're left with minus 8 equals, and then 2 times x is 2x. Okay? Notice there are no like terms here, so there are no variables here, so I can go ahead and just combine these. Negative 18 and negative 8 makes negative 26 equals 2x. Divide by 2, x equals negative 13. Okay? Next. We have 3x and 3 again, so we're going to multiply everything by 3x. The point is to cancel out all the denominator. So let's multiply this by 3x and this by 3x. So once we've multiplied each one by 3x, then we can go through and cancel the denominator. So notice here 3x cancels with that one. And then there was no denominator here, so nothing's going to cancel out. And then here the 3's cancel. We're left with x. So since everything canceled out here, we're just left with the 3x plus 4 there. Minus 3 times 3x, which is going to be 9x. So minus 9x equals, and then the 3's cancel here, but not the x. So negative 4 times x is negative 4x. Okay? Now notice I have some like terms here. That's 3x and negative 9x. So I can combine those. So it'll be 4 minus 6x. Okay, so just take 3 from the 9 and you get negative 6 there. Negative 6x equals negative 4x. Now let's add 6x to both sides. And I end up with 4 equals, and then 6x minus 4x is 2x. Okay, now let's divide by 2. And we get x equals 2. That's it. Okay. Now, over here, take a look here. We have x plus 3, and then no denominator here. So, looks like we're going to have to multiply by the x plus 3 all the way across. So, x plus 3 there, x plus 3, and then this one by x plus 3 also. Okay? Now notice here, there's no denominator, so that means I'm going to distribute here. So this really is going to be a problem like this, where you distribute the negative 3, okay? So let's do that. Negative 3 times x is negative 3x, and negative 3 times 3 is negative 9, okay? Over here, look, the x plus 3's cancel out. So I am left with just plus 1. Over here again, x plus 3's cancel. I'm left with just x. See that? Let's combine these two constants here. So that's negative 9 plus 1 is negative 8. And so I have negative 3x minus 8 equals x. Okay? We can add 3x to both sides. I get negative 8 equals 4x. Alright, and then we divide by 4. And we get x equals negative 2. Alright, one more. Actually, two more. So, like in the last one, we're going to go ahead and multiply by the x minus 1. Okay, notice these will cancel out right there. Nothing's going to cancel out here because there's no denominator to cancel it out with. So I'll just write what is left. So 1, and then minus, now notice here, this is going to be minus 1 times x minus 1 like that. So it's a distributive property, right? So negative 1 times x is negative x. So I'll put negative x right there. And then negative 1 times negative 1 is going to be a positive 1. Okay, equals x. So combine like terms, 1 plus 1 is 2, so we get 2 minus x equals x. Add x to both sides. We get 2 equals 2x. Divided by 2. X equals 1. Okay. Now, one thing I notice here is that if we were to plug in the 1 right here, we get 1 over 1 minus 1. But notice we'll get a 0 here. So 1 over 0 is undefined here. So this would be considered an extraneous solution, because if we were to plug this into the denominator in the original equation, we'd end up with a 0 underneath. So this would be considered extraneous solution. Okay? What that means is that it makes the equation untrue. Makes equation untrue or undoable. Now, you can't divide by 0, so we can't have zeros in the denominator. So therefore, if our value for x makes one of the denominators into a 0, then we must call it extraneous solution. It means it's no good. Okay, let's look at the previous one here. Notice I have a 2 right here. If I plug this into the denominator, 3 times 2 is 6, we're good there. Okay, well, right here we had a negative 2. 3 plus negative 2, that's a 1. So we're good there too. But right here, if we plug in the 1 there, we do end up with a 0 there. So we must basically say x equals 1 is an extraneous solution. It worked out mathematically, but if we plug it back in, it would just not make sense. Okay, so let's check that on this last one here. Let's multiply by x plus 4. So I'll multiply x plus 4. Now you probably can already tell here, what value of x can x not equal? If this is going to make sense, it cannot equal a negative 4. So we got to make sure if we end up with x equals negative 4, we're going to have another extraneous solution, okay? So let's cancel these out first. Right here, they cancel out. So I'm just left with those 2 on top. But right here, we have to distribute. So remember, we're distributing a negative 2. Okay? So it's going to be negative 2x minus 8. And then those cancel out, so I'm just left with plus 4 equals, and those cancel, so I'm left with negative x. Okay, combine like terms, so I have negative 8 and 4 makes negative 4, so negative 2x minus 4 equals negative x. Let me go ahead and add 2x to both sides. So I get negative 4 equals 2x minus 1x is just x. And so that means I'm done there. X equals negative 4. Well, what do you know? We got negative 4 again. So we say negative 4 is an extraneous solution. It makes the denominator 0, which would make no sense here. So this will not work here, okay? So what we say then is extraneous solution, and that's it.